Okay, carrying on from the roughing video, we'll now do the finishing pass. So the toolpath that we see on the screen there, which is pocket 1, when we highlight an option in the objects tree, the properties down below here give us all the parameters plus other ones. So if we go to the bottom of that, we can just switch the visibility off just so that we can see the other toolpaths that we're about to create a bit clearer. Okay, so we know that we've got a sketch which is that boundary of the cavity, and we can use that sketch again for the first of our finishing passes. When we created the roughing toolpath, we created a surface that had 0.5 millimeter of material left on. So we now need to create another surface with that taken off, which will represent the true surface, and that's where we'll be doing the finishing on that. So we go into surface, so we create another surface, and this time the material allowance will be 0. So that's created another surface. If we want to see any surfaces that we've created, click the plus button here and we can see the two surfaces there. So we need to think about the tools that we've got. So in this case, probably a 6 millimeter ball nose tool would be okay to do the finishing on this shape. So what we'll do is we'll use that tool to do a finishing pass on sketch 3. So we right click and say pocketing operation. Again, we'll set the step over to a larger value. The material allowance here, what we'll do is we'll set that to -3. What that does in effect is it makes the sketch 3 millimeters bigger than it is, such that the tool center line will be on the actual sketch itself. So we'll start off from the boundary on the outside, and we'll uncheck zigzag cutting so it follows the shape of the sketch and then gets progressively smaller into the center. The tool we're going to be using is that 6mm ball nose, and this time we're going to use the other surface, which is surface number 2, and the step down will be 0 because we don't need to step down in Z, we just want to take a single pass all the way across there. So if we click OK, and we'll see what that does. So that's now calculating the toolpath, and it's doing pretty much what we expect, although as you can see the step over is way too big. But that's okay because we know that the toolpath is correct. We can just set the step over now to a more realistic value. So we'll set that to 0.25 of a millimeter. Now obviously the smaller the step over, the longer it takes to calculate the toolpath, and the larger the NC program will be. 0.25 a millimeter will give you a pretty good finishing. You may need just to rub over it with a bit of emery cloth, but if you need it to be a mirror finish, then maybe 0.1 of a millimeter would be the size that you want. Okay, so we can see that it's created that toolpath there, so we can now save that away and go into the simulator. Okay, so this is the simulator again. And we can replay the different tool sequences that we want to. So if we don't want to see tool number 1 again, we just click on to tool number 2. Okay, and then we can just run that. So that's produced the roughing tool path, and now this is the finishing toolpath. So at any stage we could stop that if we don't want to see the toolpath running all the way around there. If we go to this button here, which is restart, that refreshes the part, and then we can say fast forward so that it gives us just the end of the simulation. So if we don't want to sit and watch the entire toolpath going round, then we can just simulate right to the end of the shape. Okay, so that's that toolpath there, which may be exactly what you want, but let's assume that we need to do some further finishing on the radius upstand here in the middle. It might be that the size of the step over we've used doesn't give us the finish that we want just on that one area. It might be fine on the sloping side, but might be not there. So how we do that is we close down the simulator and we go back into the machining, and again what I'll do is pocket number 2, I'll just switch off the visibility of that. So what we want to do now is we want to create a further toolpath just based on this upstand here. So again, all the machining that we do is based on sketches, so we need to create a sketch of this bottom face here. So we right click and say make a sketch from the face. So we've now got a sketch there which is the outside and inside of that. We split that sketch down so that we've just got the sketch that we want, which is sketch number 6. So we right click and say create a pocketing operation, and in this case maybe we want a much smaller step over. The material allowance is still -3mm, so that the tool, rather than staying inside that sketch, it will move it so that the tool center line sits right on that sketch. We're using the 6mm ball nose tool, the same as before. We're still using the same surface, and the clearance plane and everything else can remain the same. So that's recalculating a new toolpath based on machining just the upstand in the center of that cavity. Okay, so that's following the shape of the sketch, which is circular, so it's starting from the outside of that and will continue up to the top, but we could start from the center and work down if we prefer. So let's save that away and we'll just go back into the simulator. Now because we've used a very small step over, then obviously we'll get quite a large NC program, but if that's the what you need to produce the part, then so be it. And again we'll just run that straight forward, just fast forward that right to the end. Okay, so that's done that. So if we're happy with all of that, we can close down the simulator and then go to post-process. The post-processor is set using the setup dialog box here. So this is where we would set the post-processor that we want to use, and the program that it creates will be in the same folder as the NC program. Okay, so it's output the same folder and it's output the same name, and the file that gets created will have an extension of .pun, but if you want to, you can change that to whatever output you like. This is also where we set the tool change position, so we might want to set that to a larger value. On most CNC machine tools these days you don't need to drive the XY axis to a particular position to get it to tool change. On some older ones you do have to. So that will create the NC program, which you can then send down to your machine tool. Okay, so that's how we do that.